Well, so every time you're asked to draw a frame, you're told how many milliseconds have elapsed since the last time you drew a frame. And, so you called it roughly, roughly every 30th of a second. So you ought to see about 33 milliseconds elapse. Well, actually, it depends on what you set the clock to. But you'll know how many milliseconds have elapsed. And so you use that time parameter to control motion. So when you're calculating, let's say you're drawing a rectangle. So you've got an x and y coordinate for the upper left corner of the rectangle. You want to calculate the position. Every time you draw that rectangle, you want to calculate the position as a function of the amount of time that has passed. So it might be, let's say initially it's at 0, 0. So the position might be 0 plus time and in the x dimension and 0 plus 2 time in the y dimension. And that would make the rectangle move down more than to the right as time advanced. But it would move down to the right and go off the screen as time advanced. And that would be a pretty slow motion. No, it wouldn't. It would move 1,000 pixels in 1 second. That's pretty fast. Anything else? Did we start this? Did you start the stream? Okay. Okay. So today we're going to continue what we were talking about last time. And we're going to cover a lot of stuff. But when we're done, we will you'll be in a position to write real programs, really for the first time, because you'll know how to deal with, bring up a program that can deal with things that go wrong, i.e. can deal with exceptions. So we won't be so much limited to just writing pieces of programs, but we can write an entire program. Let me remind you what we looked at last time. So this thing is exception demo 1, and we have a method called convert1, which takes in a string. And fundamentally, what convert1 does is it calls convert2, which is supposed to convert the string into an integer, and whatever we get back, we multiply by 4 and return it. Convert2 calls convert3 and multiplies it by 3 and returns it. And there's convert3. So who could explain what convert3 is doing, what that try block is about, the try catch? Okay?
So the program will run the integer at this line. And it'll run whatever in the try statement, but if the first line calls an error, it'll immediately skip to the catch point.
Okay, so he said it right, and I'll repeat it. So we have a try block. These statements are going to be executed inside the try block. If a number format exception occurs at any point while we're executing these statements, then the control will transfer to right here, and the method will return -1. Okay? And the only way that a number format exception can occur is if parseInt throws it. And parseInt will throw it in this case because we're passing it something that's not an int. So what will happen is convert3 will get as its parameter that thing that's not an int. It'll try to convert it. It will throw an exception. The exception will be caught right here. And we return -1. So we find out something went wrong and we get a chance to recover from it. Yeah?
Can a try block have multiple catches?
Yes. We'll see examples so he asked, could a try block have multiple catches? And yes, you can, we could say catch and we could add another catch and another catch, all, on down. In this case, there wouldn't be a whole lot of a point of it because there are only a limited number of exceptions that parseInt can throw. Now you can look at parseInt and it'll tell you that it throws a number format exception if the string does not contain a parsable integer. That's the only exception that you know that it throws. Yeah?
Can we have lines in this method after the catch?
He said, can you have lines in the method after the catch? Sure. So basically, this is one big statement that contains smaller statements, but except for the fact that we return in any case, we could continue on. In fact, you could do this. I wouldn't recommend it, but you can do this. I think the original way is cleaner. But what's going to happen there when the exception occurs? Yeah?
When you catch it, but then the catch doesn't do anything. thing for them to just go out of the catch and go to
Right. So this is basically this kind of catch block is just ignores the exception. And so the exception is called, nothing happens, and therefore the catch block ends, the try block ends, and we just continue with whatever comes next, which is return -1. But that's just to prove the point that you can continue on. Similarly, if we didn't have this return, suppose we put it back the way it was. If we didn't have this return, then if the try block didn't throw an exception, if there was no exception here, it would continue on after the catch. So yeah, you can do that. Yeah?
Usually when you write methods, we just put, like, say, pointing in the try, and then do the rest outside, or do we put the entire method inside the try block?
Okay, so he asked an important question. I put all of the 3 important statements of the method into the try block, even though only one of them could throw an exception. So you might ask, why didn't I do this? Just execute the parse inside the try block and then put the rest of the stuff afterwards. Now, what problem did that cause here? Yeah? Right. Int is declared inside the try block, and so it's not visible outside. Now we could fix that. We could declare it here. And give it a value there. And then it works. Now, which version do you think is easier to understand? I think the first one's easier to understand. So if typically my strategy is if the method is simple and I want to catch an exception and do something about it, I just put the whole method inside the try and then have the catch. Sometimes, though, I have a long method that's interacting with the user. And it could be, there are multiple statements that could throw exceptions, and I want to catch them in separate places, so I connect. There we go. So let me put it back the way it was. Hey, any other questions about that? I didn't quite go far enough, I don't think. Yeah?
So can you only throw from try blocks?
No, you can throw an exception anywhere.
So in this case, can that catch executed as a try block?
No, you can't catch anything except as part of a try. So what you have to say is, try to do this, and if a number format exception occurs, do that.
So even though the number format exception is in that class method, it can only execute that number format exception within a try block.
You can only catch an exception as part of a try block. Can't have a catch without a try. Yeah? Yeah, the catch has to be right after the try. Or you can have multiple catches. Catch, catch, catch. But yeah, it's all one thing. Yeah?
So basically, we can do anything with if we catch exception.
Yeah, when you catch the exception, you can do anything you want. You could display a message. A common thing is what I'm doing here. You catch the exception, and then rather than throwing it, you return something different that indicates there was a problem. Or you could just let we could change this so the exception propagates. So speaking of that, let's look at exception demo 2. And what I've changed down here is, there's convert 3. No catch, no try. So what's going to happen when we pass this thing, and S is not an int, not a string that parses as an int? So what will happen is, parseInt will throw the exception, and it's not called anywhere in this method, and so this method will terminate by throwing that exception. So what's the next step? Okay, the method that called convert3 gets a chance to catch it. So if there was a try block around this call to convert3 that caught the exception, it could deal with it. But there's not, so convert2 throws the exception. This is often called unwinding the runtime stack. We made a call, which made a call, which made a call, which made a call, which throws an exception, which throws an exception, which throws an exception. Without any catch blocks, the exception would be thrown over here, And it would be rethrown, 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 rethrown. And when main throws the exception, that's when your program crashes. But look what I did up here in main. Now ignore the finally for right now. Focus on what's going on right here, this try block. So we're calling convert1, and it's going to throw the exception. Convert1 will call convert2, which will call convert3, which will throw the exception. Convert2 will rethrow it. Convert1 will rethrow it. We catch it here. And we print out bad integer. If I run this, you'll see it says bad integer got printed out. So you can put exception handlers anywhere, as long as they surround some method call that might throw an exception. This, you can also add to a try block a finally block. And a finally block is code that is executed regardless of how the try block is exited. So if we return normally, if we exit normally without an exception, the finally block will still be executed. If we throw an exception that's not caught, the finally block is executed. If we catch an exception, it's still executed. So you saw here, it says bad integer, and then it says all done because the finally block got to run. If I change this to a good integer and run it, what do you think it'll print out? It'll print out the integer after it's been multiplied by a few things, because that's what the methods do, but it'll still say all done. So in a finally block, you can put code that you absolutely have to have executed, no matter how the try is exited. Now, who can think of something you might always want to be sure happens, when you exit a block? Yeah? Well, usually, he said you could return something typically, but if you have a scanner open and you'd like to close it, whether an exception was thrown or not, put it in the finally block. There's even a better way to close a scanner, but we'll lead up to it. Yeah?
Was the program behaved the same way if you had the last line not in finally block, like you leave the finally block?
In this case, it would not behave any differently. But let me show you where it would. Suppose I do not have the catch. So I'm not catching the exceptions. You can have a try block without a catch as long as you have a finally. Then I'm going to take this out of the finally and put it at the end. So what will happen in this program if I give it a bad integer? What will happen to main? I call convert1, I give it a bad integer. What's going to happen? The program will crash because main's going to rethrow that exception because there's no catch. So let's see that happen. So you can see down here in the console that it reported the unhandled exception, and you don't see anything got printed out. Why didn't it print out the all done? Yeah?
Because when it crashed, it just stopped looking at everything.
Right. When it crashed, that's it. It doesn't keep executing any statements. But if we go back to having the finally right there, and we run it, that doesn't seem right. I changed too much. Okay, now we got a bad integer. There's the unhandled exception happening, but it still prints out all done, even though the program crashes. Before it, the exception is thrown from main. The finally block runs. Yeah.
Would you have a return statement when you try to catch the?
Well, you can. We saw an example over here of a return statement in a catch block.
No, then if you have a finally after that.
Yeah, so putting a return statement in a finally, I believe, I looked it up before class. I've never done it before myself, but apparently what it does is your method will just return the value. The exception will be ignored.
No. If you have a return and try a catch, and then it returns the value, we'll still proceed to the final.
Oh, sure. no matter how, if you return normally, the finally block is still executed. Yeah. So if we saw that if this is good and I run it, it prints out the thing and then says all done. Finally block always runs. Yeah. Sure, let's do that. So now we're saying, okay, do the conversion, print out the thing, and then return. Finally block always runs. So you throw an exception, you return, you just run off the bottom of a try block. The finally block gets a chance to run before you go on. Yeah?
If there were a return statement in either the try or catch things,
The finally block still runs.
so would it return the finally return value if you had a return in there as well, or would it go with?
Yeah, I believe. So what he's asking, the answer is the question was, what happens if there's a return statement in the finally block? It's part of the question, and I believe I've never done that, and I don't think it's good programming practice. But whatever is returned from the finally block would be what's returned by the method. But I don't recommend that. It's sort of an abuse of finally block. So I'm going to put this back in the shape it was in, so when you look at it later, it makes sense. Okay? And we're going to look at another example. Except I can't remember what it was. This one was supposed to illustrate. That looks just like the last one. Anyone see anything different about this one? This doesn't have the finally block. That's the only difference I see. Ah, I know what happened. I meant to show this one first. Right? Because that's the catch. And then I said ignore the finally. Then I meant to add the finally. I just numbered them wrong. So anyway, so we've done both of them now. Good. Okay. Hopefully this one is numbered right. Okay? So let's see what's happening here. Let's go down to the method. And I've just put in code for the heck of it that checks to see if S is specifically the empty string. If it is an empty string, I throw a runtime exception. There are lots of exception types built into Java. Runtime exception is one of them. And so this is how you, in your code, can throw a runtime exception. You don't have to throw an exception. You don't have to depend on methods you call to be throwing the exceptions. You can decide to throw one yourself. So I've changed convert3 so that if S is the empty string, we just, for the heck of it, throw a runtime exception, and it'll contain this message, empty string. Otherwise, we go like before. And so if there's a number format exception here, then the it'll propagate. So this method could throw one of two exceptions. So you can see up here, I've written it to catch both of them. So I do the conversion and print out the result. If a number format exception occurs, what am I doing here? I'm just printing bad integer like before. If it's a runtime exception, though, I'm going into the exception, pulling out its message, and printing it out. So let's try this out. I run it with a bad integer. It says bad integer. If I run it with a good integer, then I get an integer back. And if I run it with an empty string, it says empty string. And where did that empty string come from? Because you don't see it. You don't see the word empty string on the screen right now. Yeah? Right. It just calls, every exception has a get message method. And down here, when I constructed the runtime exception, that's what sets the message. So I was just printing that out up above. So there are a whole raft of exceptions. If you use a bad index into an array, you get an exception. Array index out of bounds exception. Exception names tend to be long, very descriptive. So there are lots of methods are going to have exceptions, and that you'll see from time to time. Yeah. The one okay, you're asking about the assignment this week? No, you don't have to deal with exceptions this week. Next week, I'm going to ask you to write a program that's more or less bulletproof, that interacts with the user and deals with mistakes the user makes. Yes? No, I can't give you any information about it yet, but I will Thursday. Yeah?
Would you throw another exception besides the runtime exception?
Could I make it throw a different one? Yeah. I could. I mean, this runtime exception is very generic. I could say array index out of bounds exception, except I think that's a capital O. That would be a bad exception to throw. It's misleading, but an exception. You can't throw any old object. We'll talk later about what makes an object something you can throw and what you can't. But for the time being, all the built-in exceptions end with the word exception. So, yep.
In Java, can you use indexes like -1 and -2 to count from the end?
Because so he's asking in Java, can you use negative indexes into arrays? Lists? No. It has to be non-negative. Yeah?
Can you explain again how the get method works? So if you throw an exception, or if you throw a new exception, does that mean that anytime you see that?
Well, right. This throws an exception, and well, I should put it back to runtime exception. This throws an exception whose message is empty string. And so anyone that catches that exception can extract the message. Now, we could do this up here. When we get the number format exception, instead of printing out bag integer, we could print out e.getMessage. Now, what message will it print out? What message will that exception carry? Any ideas? Yeah. Say what? Well, it depends on where was this message, where was the exception object created? Somewhere in parseInt. So we didn't create this exception. So the Java library is creating it, and it's just whatever they set the message to. Let's see. So I'll just try to convert x into a number. And that's the message that the library put in there, for input string x. So it's telling us it was trying to parse x as an integer, and that didn't work. So any exception you catch, you can look at the message. Sometimes they're empty. It just depends on what code created them. Yeah?
Can you make it so that if an exception is thrown, it gives the user another chance to throw again?
Okay, so we ask, could we make it so that if an exception is thrown, you give the user another chance? You can write your program to work that way, and we'll look at an example shortly here. Yeah, you can catch the exception and try again. Okay, let's look at, that's step one. Let's look at step two. So let's look at what this one is doing. So I have a method down here called print first line 3, and let's see what it does. It takes a path name. So the one I'm passing down to it is that. So that's the folder on my computer. So I'm passing that string down. It passes, like these other examples, it goes through print first line 1, print first line 2, to print first line 3. So we take that path and create a new file object out of it. Then we open a scanner that reads from the file. We read the first line from the file, we print it out, and we return its length. And if that file doesn't exist, so if we try to open the scanner and it can't open that file, we're going to catch the exception here, the file not found exception that's thrown by the scanner constructor, and return 0 instead. So let's see how that works. The point to realize is the path name we're passing down is not a path name of a file, it's a folder. So that exception is going to occur. It's not something it can read lines from. So I run it, and I get the 0 back. So the exception occurred, and 0 was returned. Yeah? Well, he's asking, can you only read lines from a .txt file? It just depends on, I mean, typically, if you have ASCII text that's readable by a scanner, it'll be in a .txt file, but there's no rule for that. There are other types of files you could read an XML file with a scanner, for example. Okay, so if I fed it a path name for a real file, let's try that out. So what I'm going to do is copy this line here. Comment this one out. And I believe I have one called animals.txt. Except that's not spelled right, and I think it's in my documents folder. I may be wrong about this, and we'll regret doing this, but let's try that out. So now, hopefully that's a real file, and we'll find out how long the first line is after it's been multiplied by a bunch of things. Okay, so the first line was elephant. And then it returned the length, but that length got multiplied a few times on the way back up. Yeah?
So that first file didn't exist, is what you said?
The first file was a folder. And since it was a folder and the scanner can't deal with a folder, and so it didn't throw quite the right exception, right? File not found. It found the file, it just wasn't a file. So I guess in a sense, that's right. solve our. Well, that's sort of the suggestion we had before. Let me just show you what you can do. When you hover the mouse over here, it'll give you two quick fixes. Surround with try-catch or add a throws declaration. We're going to do the second. So what has changed about the method? Let me make it so you can see what changed about the method. What did we just do? Yep? Right. This was added. So here's the deal with checked exceptions. Either you catch them or you advertise in the header of the method that your method may throw such an exception. So you've either got to catch it and deal with it, or you've got to say in your header that you may throw it. Now this throws students for a loop because it looks a lot like throw. Okay? Throw, if you say throw exception, you're throwing an exception. When you say throws in the header, you're not saying it will always throw the exception. You're just saying that it may throw the exception. So a better keyword than throws might be may throw, something like that, can throw. You're saying it's a possibility. Yeah?
So if you don't tell it what to do when it gets that exception, and you put that in it catches it, what will it print out?
Well, if you don't catch it, what's going to happen is if this exception occurs, is the exception will propagate. It will throw the exception. Okay? And it'll either, if it's not caught, it'll cause the program to crash. Just like before. So the difference is with the checked exception, if you want to propagate, you've got to advertise that fact in your header. Now, since it's advertised in our header, what happened to poor print first line 2 right here? Yeah, it is now calling a method that may throw a checked exception. So it either has to catch it or advertise that it may throw the exception. It sort of propagates this way, right? This guy here is now calling an exception that may a method that may throw that exception, so we have to add the throws to it. And then we're up here. Now up here, let's deal with it. So up here, let's put in a try block. Actually, I'm just doing too much typing here. Let me show you what you can do instead. Go back to the way it was. Let's just take the suggestion here. I could add a throws declaration to main, but I want to catch it. So I'll say surround with try catch block. And you can see it ended up just putting the try catch block around one statement. I want it around both of them, so I'm going to do a little bit of rearranging here. That saves me a bit of typing. And then what should we do in the catch block, do you think? We can just print something out. Couldn't read file. Great. So now if I run this, it'll say couldn't read file because the exception propagated all the way back up to me. So the only difference with the checked exception is you've got to do something. And often what you do is you just let it propagate. But you've got to advertise the fact in your header. Yeah?
So what happens if it throws a checked exception, but you haven't put the warning that it might throw an exception?
Okay. He's asking what happens if you don't advertise it and don't catch it. The answer is your program won't compile. It's just an error. You got to do it if you want to run the program. Yeah? Oh, he's asking why not put why not just put a catch in? Well, why might we not want to put a catch down here? Why not? I mean, why not just put a try catch there and not deal with it? Yeah. Say what?
If you catch it here, you don't have to throw.
Right, but why might that not be something you want to do? Yeah.
You might have other methods that throw the exception within the main that can be caught later on.
Okay, there might be other methods that throw that exception. You can catch them all in main, yeah?
So, because this method was called in other methods, but you don't necessarily want those methods to do anything with what you're, like, with whatever you're catching here. Like, if you're, like, returning, I don't know, -1, you don't want to bother with the other methods because you don't care what it is at that point.
Okay. So here's the bottom line. You may not know what to do about it. The job of that method is to print out a line and return a number. It may not have any idea what it should do in the case of that exception occurring, and so it just passes the buck and makes it the responsibility of someone higher up on the stack to decide what to do about it. I mean, it may be the exception is thrown in a method that does no input-output, it's just reading files. And the input-output stuff, the user interaction stuff, is being done up in the main method. So this poor method down here that deals with files, it doesn't want to start interacting with the user. That's not its job. So it throws the exception and lets someone else deal with it. So it's not always convenient or possible to deal with the exception where it's thrown. Makes sense to let it propagate up to where some other method can deal with it where it's appropriate to deal with it. Yeah.
If the main method throws an exception, would it just crash? Or?
Yeah. So what he asks is about the main method throwing an exception. Yeah, that's what causes your program to crash with an unhandled exception, is if the main method throws. And, you know, for little toy programs rewrite, that's not so bad. But for a real production program, you don't want your main method throwing exceptions and causing the program to crash. Instead, what you often see happen is like a little window will pop up and it'll say, oops, something went wrong, try again. What that means is probably some unhandled exception propagated to the top and was caught, and they just displayed this all-purpose oops message and set it up so you could try again. Yeah. Yep, you could set it up that way with a loop. So that's what makes it try again. Yeah.
Kind of unrelated. Is there just a general catch statement?
He asked, is there a general catch statement? Yeah. You have to say what kind of exception you're catching. But it is possible to just say catch exception. So every exception is a exception, right? So that's your general purpose catch. That'll catch any exception, no matter what it is. Explaining why this works involves talking about inheritance and subtyping, which I don't want to do right now. Well, if your goal is to bulletproof your main method so that no exceptions get through, that's what you would do. You would wrap it with a catch of any exception. And what you want to do is catch the exception, log it somewhere, because it's probably a mistake you need to fix, and then give the user some, let them try again or something. Yeah?
So your example about a window popping up and saying, oops, try again, they pretty much did that?
Yeah. Right. So imagine putting this try-catch in a while loop, and if you ever catch an exception up here, you say, try again. And then it tries again. We'll see an example like that. I keep promising it. We'll get there eventually. I think we've gone long enough without a break, so let's take a few minutes here. And we'll continue from here. Okay, let's start again. All right, here's a simple method. It says obtains a number from the user and displays its square root. So what am I doing? I'm saying show an input dialog, enter a non-negative number, and then I am parsing the double that I get, and then I'm showing a message dialog, the square root is. I want to make this more bulletproof. What could the user do wrong here that would make this crash? Yeah. They could input a negative number. What else could they do wrong? Yeah? Well, 0 is okay. But you could enter something that's just not an int. Okay? So what I'd like to change this is so that we catch the exception when it occurs and tell the user they made a mistake and let them try again. So how could we arrange that? Basically, just keep going until we get something we like. Yeah?
We could put a try catch.
Okay.
Error that first double measure.
Okay. Okay, so let's see. Let's catch the number format exception. I want you to notice that I quickly reformat this so it looks presentable. Okay, so we're going to do all that inside a try block. And what should we do if there's a number format exception? Yeah? Okay, so let's do this. And just to save time, I'm going to say show message. I'll just say bad input because I'm lazy right now. I don't want to spend all this class time typing. Okay, so we'll say bad input. Now I want to, again, ask for a non-negative integer. Well, return isn't what I need. What I need to do so that after it says bad input, it repeats. Yeah?
We can put the whole thing in a while true statement and then you continue.
Right. We can just use a while statement here, and I can just say do this forever. Okay, so we can compose these things. This is programming. You take the building blocks you know, and you compose them to get what's the effect you need. So what's going to happen now is it'll try to interact. If there's a problem, it'll say bad input. Then it'll do it again. So let's try that and see how well it works. So I'm going to enter garbage. It says bad input and asks me again because the loop's repeating. I'll enter more garbage. It says bad input and tries again. I'm in an infinite loop. Now what happens if I enter good input? It'll give me the square root and it'll try again because it's in an infinite loop. So that's good. What's it going to take? How can we end the loop once we have succeeded in producing output? I heard a break, I heard a return. Either one will work. Return's probably, I'll just do return. Break would work as well. We've got to break the loop somehow. So now it'll keep prompting us to enter numbers until we finally enter one that has a square root. Yeah?
You also just call the main method in the catch statement, so that you only call the main method.
Okay, so he's asking, could the main method call itself to repeat? That's called recursion. And yeah, we could arrange that to work, but it's not the best solution in this case. It's very wasteful of memory, so we'll stick with this one right here. Now, maybe this is a feature, not a bug. Maybe you could argue, I don't want to return. This thing just runs forever and gives you square roots. Why not? But we need to give the user a way to say, I'm tired of giving you input. So, it turns out that show input dialog returns null if the user pushes the cancel button. So what we can do is test right here. If the input is null, return. So this, by the way, is the only place where I tend to write an if without braces. If its job is just to return or to break, I do it that way because I think that's easier to read than putting the return in braces. So that's just the one exception to my formatting rule. Okay? So now, how's this going to work? You know, when the user hits cancel, input will be null. Now, I've never told you about null before. Basically, null can be stored in any reference variable. So anything that refers to an object, to a string, to a scanner, you can store null in that. So null is a reference to nothing. It's just a placeholder. And it's often returned to indicate there was some exceptional condition that happened. So often you find yourself checking to see if something is null, like I did right there. So no big deal about null. You see it's a special value because it's highlighted there. If I run this now, enter a non-negative integer, I'll enter 88. Okay, it gives me the square root. Enter a non-negative integer, I cancel. Gone. It's just because that dialog returns null when the user hits cancel. Great. Now, are we done? Is there any other error the user could make? Yeah?
Would you know how to handle a negative number?
Right. What's going to happen if we do a negative number? Let's try that out. So I'll run it. I'll say -9. And it says square root is not a number. That's because with double arithmetic, if you try to take, if you do some bad computations, it actually gives you a double back, which is NaN. That's not what I want the user to see. How can we make it more robust if the user enters a negative number? Yeah. Right. Right. We can say, after we parsed it, we can say if x is less than 0, now, what should we do if x is less than 0? I'm going to do this. Just because it's possible. We'll just throw an exception. Yeah?
I have a question about the null. If you don't enter anything, is that considered null or is that considered 0?
Well, okay. He asked a question, but I'm going to answer it without telling you the question. Null is different from an empty string. Okay? Empty string is a string with no characters in it. Null is just a placeholder that says, I don't have a string for you. So null is just a value you use when you don't have a better value to use. When you want to say there is no object reference from this variable, you store a null in it.
So through an exception, return that input?
Well, if you try to do something to the null string, if you try to find its length, you'll get a null pointer exception. So if you ever see a null pointer exception, it's because you tried to do something. Call a method on null. Typically that's it. You try to call method on null. Yep?
A method like this, wouldn't it be more convenient to put a throws statement in the header?
Put a throws in the header. Well, I don't want the thing to crash. I want to deal with it. What happens when I throw this exception? It's caught right here. So what I did, I started to say if x is less than 0, I was going to do this. And I decided I'll just throw the exception and let it be caught down there. So you can throw an exception and catch it in the same method. So now we got it pretty much like we wanted. If I run it, if I enter like -99, it says bad input and asks for more input. If I give it garbage, it says bad input. If I enter good number, it tells me the square root. And if I click cancel, it's done. And that's just a combination of checking the input, like right there, or catching exceptions. So when you end up writing a program that interacts with the user, that reads files, you end up writing a tremendous amount of code just dealing with things that can go wrong. You often end up writing more code dealing with the exceptional cases than you do anything else. Yeah?
So before you put that null statement in there, if you would have hit cancel, it would have just popped the box up again?
Yes. Yep.
If the entry is a bigger number than I can handle, what will it throw? If the number is too big of a number?
Okay, so he's asking, what if you give it something that's all digits, but it's just too big to be an int? All right, I think that's too big to be an int. Oh, it was too big to be an int, but it's not too big to be a double. So to do that, I've got to do something like 1 times 10 to that big. I'm sure that's too big to be a double. I think it's going to say the square root is infinity. No. Doubles are a little more robust than ints. Basically, it took that big number and it's treating it as infinity. We would just have to, after we parse it, we could check to see if x is equal to infinity. I'm not exactly sure how to do that. But I imagine there's a constant in the double class, but I won't waste time flailing around looking for it right now. Okay. Was that step 4? No, this one here. All right, now we're going to look at another use for try blocks. I told you we'd cover a lot today. There's sort of we're just to the point where we can do interesting things now. So let's see. This is our program. It's going to try to read the first line of something that doesn't exist. It's going to print out. We've seen this method before. So I want to focus on this down here. We're creating a new file, but look at how I'm opening it. Look at this right here, how we're opening the scanner, how we're creating the scanner. So this is called try with resources. So this was added something like Java 7, which is like probably 15 years after the first version of Java appeared. This was added sort of late in the game. Maybe it was Java 5. And they sort of had to reuse the try keyword. So if after the try and before the braces you put in parentheses something like this, then that thing is automatically closed when control leaves the try block. So if you return from the try block, the scanner is closed for you automatically. If you throw an exception inside the try block, the scanner is still closed. If you just execute out the bottom of a try block, the scanner is still closed. So you don't have to worry about something going wrong and not getting a chance to close the scanner. So when you open things, open them with one of these tries so that you get the close automatically. Now, you can't put any old statement here. The thing that you are creating in here has to be something that is closable. A scanner, it turns out, is closable. So anything that you need to close, just open it that way, and it will close for you automatically. So from now on, when you open scanners, open them with a try with resources is what that's called. You can put catches on the bottom of this as well. You don't have to in this case because the try is doing something right there. Yeah?
So once we close the scanner, can we use the SCN as a variable here for something else?
SCN is only usable inside the block. So the things that the variables you declare here can only be used here. Okay, so that's easy to explain. Now, let's see the second one here. This is what you'd have to do. Okay, this is where something goes wrong. What's wrong with just opening the scanner and then closing it right before you return? Just straight line code. You'll see right here, I closed the scanner. Yeah? Right, what if an exception is thrown when I create the scanner or while I'm reading the scanner? Then the scanner doesn't get closed. That's why we do that try with resources. Let's look at this approach. Now, that's same as the other approach. I wonder if I put something out of order again. Okay, I'm not sure what I was after here. I could have sworn I had an example that would show you how to do it with a finally block, but somehow that got lost. So never mind that. That's how you open something that needs to be closed. Okay. Now, let's look at another example. You can close, it's just the main point was, even in using a finally block to close the scanner, it's a lot easier to use try with resources. That's the takeaway. Okay, so now I want to do something. I want to open a dialog, ask the user to select a text file, open a scanner for it, and say the file contains some number of lines. Now, what's it complaining about here? Why do you think it's underlined in red? Yeah? Right. That's a checked exception, file not found exception. So that's not going to fly. How can we fix it? Yeah? Okay. We could try to use a try catch to do something. But what else can we do? Yeah? Say what? We could put the throws in the title, but I want to catch the exception. While I'm at it, how should we be opening the scanner? Right, so I'll create the try block this way. Okay, so I'll cast a file not found exception there. I need to import that, and then I'll display some sort of dialog here. I'll say couldn't open file. All right, so I just changed the program to, first of all, use try with resources to open the scanner so it'll get closed for us. And then if there's a problem, I display a message. So this is supposed to obtain the file from the user and display the number of lines it contains. So you see that it opens the scanner from a file, not from a string, and it just a little accumulation loop. It reads a line, increments count, reads a line, increments count, then it prints that out. So if I run it, it brings up this. This is another kind of dialog in the library I gave you. So let's say I pick animals there and open it. It says that contains 7 lines. On the other hand, if I run it, the dialog comes up and I give it some garbage, it'll say it couldn't open the file. But either way, the scanner is cleaning up after itself because of the way I'm opening it there. All right? So just another example of how you can use the things that we've learned about to give the user a better experience. Yeah?
What would happen if you selected a real file, but it wasn't like a text file, it was like a picture file?
Well, we'll see what the scanner, let's see what the scanner does for that. Let's see. It's a PowerPoint slide. I got so much crap in here. That looks like an image. Yeah. So yeah, the scanner just wasn't able to read it, I guess. Yeah?
Can you place the file declaration with file doc?
Yeah, we could have put the file declaration in the try block, yeah. Yeah?
You read like a Word or a doc file?
Well, I don't know what it'll work for files that contain ASCII text, and you can play around with it if you're really curious. Yeah?
Well, how about if you forget to close the scanner? Does that open the file?
If you forget to close the scanner that's reading from the file will stay open for a while. It's usually not a big deal unless you're writing a program that runs forever. Then you may end up with so many files open that the program can't open anymore. So it's not a problem with this one because it reads a file and then exits. It's not like the file will stay open for eternity. It'll be closed as soon as the program ends. Yes?
So for this one, if this was running longer than just like milliseconds, would you need to close the file or close the scanner afterwards?
Well, we are closing the scanner afterwards. He's asking if this were running longer than milliseconds, would we need to close it? But yes, it's being closed automatically because we're opening it with that try with resources. So we don't have to actually call close. It's just done for us. So there's just no reason. Well, sometimes there are reasons sometimes when the control flow of your program makes it so you need to close it manually. But 99% of the time, this is how you want to open something that can be closed. Let it be done automatically for you. Why not? Yes? So he's asking about more details of how you know something's closable, and rather than go through it, I'll just say yes. Okay. So he knows the answer, and the question doesn't matter to anyone else. So, okay, let's look at another example. Now let's see what this program does. It prompts a user for a file, then it sorts the lines it contains, and then displays the line that's in the middle of the sort. Okay, so we'll just read a bunch of lines from a file, sort them in order, whatever order Java sorts things in, and then we'll just look in the middle of the sort and pull out the thing that we care about. So let's see what's going on here? So we're opening that up, the file. If the file is null, we return. We create a scanner. We have a method called find median line, which returns that, and we print it out. Now, having looked at this, I realized I should have done this a different way. I want to open the scanner in a try with resources, like I was telling you. So I need to follow my own advice. Okay. Now, what's it going to take to find the median line? Let's think about that. What's it going to take to read all the lines from the file, sort them, and then find the one in the middle? Say that louder. Well, let me propose something different. Can we use an array for this? Can we read all the lines into an array, sort the array, and then look in the middle? Seems like we ought to be able to, but there's a catch. Yep. Okay, so but why can't we use an array? What's the problem with an array? Yeah. No going in how many lines are to read. So to use an array, we'd have to read through the thing once, figure out how long it was, then read through it again, allocate an array of the right length, and read through it again. So there's an alternative, which I am going to just show you right here. There's a class in the Java library called an array list. So on the left, we see how to do things with arrays. And then on the right, we see how to do things with array lists. So you see, you know how to declare arrays. That's how you declare an array list. You have to use angle brackets to say what type of thing is in the list. So that first thing says we've got an array list of strings. The second thing says we have an array list of integers. Now I'll explain why it's spelled that way instead of int in a second. Then you see how to create a new array list. You just say new array list of strings. You just call in the constructor with no parameters. To get something out, you say a.get. You give an index. To change something, you call a.set. So there's a get method and a set method. There's a size method, tells you how long it is. And then there are various ways to add and remove things. So a.add adds something to the end of the list, of the array list. A.remove would remove something from index 4. So these are less efficient than arrays, but much more useful because they dynamically size. You can grow and shrink them. Okay? Now, there's all kinds of fine print, which I really don't feel like going into today. So let me just tell you, if you want to store an int in an array list, you can't say array list of int. You have to say array list of integer. I'll explain someday why. If you want an array list of doubles, you got to spell it with a capital D. This just seems completely arbitrary, and in a way it is. Char, you got to spell character boolean with a capital B. Bottom line is, array lists cannot contain primitive values. They only contain objects. And those things are objects. So capital I integer is an object that contains a single int. From your point of view, it'll look like you have an array list that can contain an int. Just spell it integer and say int everywhere else. For types like strings, it doesn't matter. Okay, so back to our program. So what kind of method will find median line be? What will it do? Yeah. No, how will we code it up? What will it have to do? Yeah. Well, how's it going to know the number of lines? So it's going to read lines from the scanner. What's it going to do with them? Add them to an array list. Now you have an array list containing all the lines that were read in. Then we sort that. There's a built-in method to sort it. And then we just figure out what the index is in the middle. So let's look at the method. Array lists are really easy to use, easier to use than arrays. So let's look what I've done. Right there, I've declared a new variable called lines which is an array list of strings. And I create an empty one by saying new array list of strings with no parameters. That's just calling the constructor. Now I have an empty array list. Now, as long as the scanner has a next line, I get that line and pass it to the add method on the array list. So after this loop has run, what's going to be the state of the scanner? What can you say about the scanner? Yeah. It'll still be open, but what? Yeah? Yeah, there are no lines left in it because you've sucked it dry. What will be the state of that array list lines? Yeah? Yeah, it'll have all the lines that were in the scanner. So element 0 of lines will be the first line read from the scanner. Element 1 will be the second line read from the scanner, and so on. If that file had 1,000 lines, the array list will contain 1,000 strings, one corresponding to each line. So I've got a little problem if the size is greater than 0, if not greater than 0. So I wrote it so that if the size is not greater than 0, in other words, if the file was empty, I throw an exception. But if it wasn't empty, I sort it. So there's a method called collections.sort that'll sort a list. So I sort it, and then I go and I look what's in the middle. I just take half of the size, and that's the middle of the list. I pull that out and return it. Yeah?
How does it sort the lines? Just by size or alphabetically?
He says, how does it sort it? It sorts it roughly alphabetically. It's called lexicographically. It sorts them in the order that Unicode occurs in. Yeah? No. Collections is just a class that contains static methods that are useful for things like array lists. Yeah? Okay, he's saying if there's an even number of lines, there's really no middle, so I'm not sweating it. I just take one close to the middle. Okay, so that shows you how to create an array list. Up here, let's see what happened. So I get the median back, and I display it. So if I run this, okay, I can do something like, I happen to have Pride and Prejudice here. We can open it, and that's the median line in Pride and Prejudice. Cause of it, I need not explain myself farther, and though we know. Okay? So it's not a toy example. It sucked in the entire text of Pride and Prejudice and told me the median line. Now, it surprises me, though, that the median line starts with a C. You'd think it would start with something closer to the middle of the alphabet. Yeah?
Lexicographically, would like punctuation show up before letters?
Lexicographically, some punctuation would show up before letters, others. It's all mixed up in Unicode. If all you're dealing with is lowercase letters, it's alphabetical. Okay? Now, I don't have time to go through in detail another example. I just want to point this out so you can look at it. I have a class, it's in the same thing, it's called median int. And instead of reading a text file that contains anything, it wants to get a text file that has nothing but ints in it. And it computes the average, and it computes the median. And that's no big deal. But there's this method here called find median int. What do you suppose it looks like? Yeah?
It has a try catch with the when it's trying to do dot next in to a scanner.
Okay.
Next thing it gets is
Okay. And I actually misstated. This one only computes the median int. It sorts them and finds the one in the middle. Find median int is virtually identical to find median string. The only difference is we're reading ints, and so we use an array list of integers with a capital I, all spelled out. But anywhere else in here, we just deal with ints. So you can see what it does is it just reads them in, stores them in the array list, sorts the array of integers, and then gets the middle one out and divides it by 2. So the only place you should need to write integer with a capital I, most of the time, is when you want an array list of ints. Anywhere else where you use that array list, just spell it normally, int. Okay? So we've sort of raced through a lot of material here. We'll revisit it Monday, but your next assignment will involve these sorts of things, interacting with the user and dealing with files, trying to make your program bulletproof.